Welcome to part 3 of the Metal Building Manufacturers Association MBMA presentation series on fire resistance design for metal building systems. This part is focused on fire resistance rated columns and roof ceiling assemblies. I am Nestor Ivancu, Senior Engineer with Jensen Hughes, and have also served as the Fire Protection Code Consultant for MBMA over the last 10 years. Brief disclaimer, please note that while every effort has been made to accurately review and present the information given, it is assumed that the design professional is competent and is responsible for the design. In particular, the building code of record may be different than what is presented in this information. The final design and the approval of the design is at the discretion of the local authority having jurisdiction. Part 3 will cover the fire resistance rated column and roof ceiling assemblies that are prevalent and developed for metal building construction. We will also look at some alternative computational methods for determining gypsum board protection for steel columns and present an example for adjustment of spray-on fire protection thickness based on steel column size. And finally, we'll show you some photos of a before and after fire test of a roof ceiling assembly. The remaining parts 4 and 5 of this series will be on fire resistance rated walls and continuity joint assemblies developed by MBMA. This is a summary of the various fire resistance assemblies developed by the Metal Building Manufacturers Association. You will see the same summary on the MBMA website. Again, the link will be provided in your video notes. And as we scroll down, you will see the same table. The various orange highlighted assembly numbers are direct links. So if we're looking for a column assembly, which is the very first rows of this column, you can actually connect up. And if we want to look at X524, we can hit this link and we will jump directly to the UL online database, and you will see this assembly and all of its listing requirements. So here are the assemblies that we will be focused on in this part 3, the columns, X, 524, 530, 531. Again, recalling the information that I gave in an earlier presentation about the alphanumeric system, X, the alphabetical part signifies columns, and then the 500 series means fire protection via gypsum board membrane enclosure. Roofs, P is again the alphabetical symbol for roofs in the UL system, and then 200 series are your acoustical assemblies, acoustical protection. 500 series is again gypsum board. So we'll start with the column assemblies that MBMA developed. I showed you a few slides ago how to directly connect with the UL X524 listing via MBMA website, and so we'll just briefly highlight what's contained in this column assembly. It's for 1 and 2 hours. It covers built-up steel columns and gypsum board protection. It gives you all of the details on how to enclose the steel column in the gypsum board, and the types of gypsum board, the number of layers, and the thicknesses of the board that are required. Most importantly, or one of the important limitations, is the minimum size of the required column, and this is pertinent to any and all assemblies. Typically, a minimum size, that's the size that was tested and rated. One can use that assembly and apply it in actual construction to any size larger than that, but it's not applicable to any size smaller, because a smaller steel shape is more vulnerable to heating and fire effects than a larger shape. So the minimum size is a very important requirement in these assemblies. Another column assembly that has been around for a while, is also for 1 and 2 hour ratings, is a cold formed C-shaped column. This is very unique assembly, and it's one of, I think it's the only cold formed column assembly in the UL directory. And it also is significant because it probably has one of the lower minimum W/D ratios, so the minimum sizes that are allowable for fire resistance rated construction. Again, it will give you the various requirements in terms of the gypsum board, brands, types, installation details for 1 and 2 hours. Another design option, is for pipe columns or hollow structural section columns, and this one is for the circular column X531. It has a 1.5 hour rating, and again, gypsum board construction. It's got the framing angles around the column itself for installation of the board enclosure. So you have 3 different kinds of column assemblies depending on the size and the shape of the column that you're using, and they are good for 1 up to 2 hours, in this particular case for the round column up to 1.5 hours. Now let's look at a computational alternative, a very nice and a powerful formula that can supplement just the prescriptive ratings given in the UL assemblies. This provision is in the International Building Code itself. It's also given in other publications, in the Gypsum Association, and also AISC design guides. Basically, what it gives you is a formula for fire resistance based on the heated perimeter ratio of the steel column itself. Any type of type X wallboard, so it's not manufacturer brand specific, as long as one uses type X wallboard enclosure. And that is the very nice feature, because many of the UL assemblies, including some of the ones, the MBMA sponsored ones, are specific to proprietary gypsum board products, and that is the limitation that must be used for those applications. If one uses and makes references this part of the building code and uses this calculational approach, again, it's any type of brand manufacturer as long as it is type X wallboard. This is a linear function, as this plot shows, the fire resistance time in hours versus the weight to heated perimeter ratio of the steel column on the horizontal axis, and the various lines, color-coded lines, are for 1, 2, or 3 layers of 5/8 type X board. You can see, obviously, with the 3 layers, the yellow line, you can get the higher ratings than you will with 2 layers and 1 layer. Again, depending on what your W/D of the column is, You can use this or similar graphical aids to estimate, or even the formula itself to back calculate how many layers of board you will need for a given hour rating. And we will use this chart and the IBC formula in the following example as an illustration. So here's an example illustrating application of this IBC code provision on gypsum board fire protection calculation for a steel column. Our example postulates that we need to determine 1 hour protection for a light gauge steel column with a W/D equal to 0.3 pounds per foot per inch. So we're given a W/D. We need a 1 hour rating, and what is our protection? What is our protection solution? So there's two ways to approach this. One is just to use the very first assembly that we talked about in this presentation, UL X524, which is your proprietary UL rated assembly. And then we'll use this IBC gypsum board formula, and we'll see what the similarities or differences may be. So let's proceed with this example number one. One solution via Underwriters Labs X524 assembly. The minimum W/D required is 0.27. We're at 0.3, so we're fine. We're greater than that, no problem. The assembly requires 2 layers of 1/2-inch thick Type C board. Type C board, recall, is the highest performance fire resistance board. Only specific brands and manufacturers are allowed in this design. So if your contractor is out of stock or has a lead time in ordering this board, there may be some issues and problems. So an alternative is to do this via calculation, using the IBC equation in the plot that I showed you. And basically you can estimate that 2 layers, 5/8" Type X board, again any brand, any manufacturer, will be sufficient. And we can also numerically and should numerically check via equation, and we'll see that with 2 layers of 5/8 board, 1.25" total board thickness, we get a fire resistance rating of 72 minutes. And we can see this in the plot itself. This is a repeat of the plot. We're just highlighting where we are in this plot. So we have a W/D of 0.3. We require 1 hour rating, and actually with our 2 layers of board, we're on this pink line, and we're providing about 1 inch or 1.25 hours of fire resistance. So that is our solution via the IBC provision. So again, the benefit of this would be that if you don't want to use or be limited to the 1/2-inch Type C board and specific manufacturers that are listed in UL X524, you have this option to use 5/8 Type X board protection. The result is a 1/4 inch more thickness of board, but that may be a secondary consideration if the Type X board is readily available and potentially less expensive. So again, just another option to the UL assemblies, and a very nice option and easy option to apply. Another similar example with spray-on, and this may not be as commonly applied as board in metal building construction, but it again illustrates the point that one way or a good way to minimize the required thickness is to actually make use of these computational allowances that are given in the IBC and in UL to minimize the thickness of your fire protection, and not just use the the minimum shape size that's given in the assembly. So let's say we have a very small column, W6 by 9, with a W over D ratio of 0.33. We'll use a UL listing that will show 13/16 inch SFRM, or spray-on fire resistive material thickness for this case. And here we will just illustrate that there's an alternative formula, that ULX772 for this particular product, and we're assuming monocoat spray-on material will be used. And it's applicable, this equation via this assembly is applicable to any W over D column between 0.33 and 6.62. And again, it's an easy calculation to make. If we make this calculation, we will see that the requirement is 0.82 inches, almost identical to what was specified for 13/16. And it just, again, the illustration is just that there's another way via the formula to calculate a thickness based on member size rather than using the thickness for the minimum required size of a given assembly. Now some roof ceiling assemblies that MBMA has developed. One of these is your gypsum board ceiling, and this is P516. This is a 1-hour assembly. Typically here we don't, for metal building construction, we don't need to go any higher than 1 hour. So 1 hour is the maximum that has been developed. This assembly uses a membrane ceiling, gypsum board, framing system suspended from the roof beams and purlins, as you can see. You have a roof deck on top with some fiberglass insulation underneath. There are some minimum cavity dimensions and other requirements in the assembly. Again, if you wish to look at the details, go to the MBMA website, punch on the orange P516 as I illustrated earlier for the column assembly, and you will find all of the details on the requirements. The other two assemblies that were developed a number of years ago are both acoustical ceilings and require or involve proprietary systems. One is Armstrong and the other one is USG, US Gypsum. These have a lot of extra bells and whistles in terms of lighting and HVAC allowances and that, but again, the system is limited to these two manufacturers, and for the most part, based on comments that we have heard, these are not very often used in metal buildings. Here is the other USG counterpart to the Armstrong ceiling assembly, P268. It's rated for both 1 hour and 1.5 hours, and it's in general it's pretty similar in terms of the construction. Just the acoustical ceiling system and the allowances are particular to the USG system. There are some other alternatives. One of these is an Intertech Laboratory assembly. The numbers are there. It's good for 1.5 hours, and basically it makes use of a proprietary insulated panel. This is a with mineral wool insulation, pre-manufactured panels. Again, this is valid and can be used if one sees a design need for such. Just to give you a feeling for both the standard fire resistance tests that are done on which these ratings are based, what one might expect after a fire in a fire-resistive assembly. Here's a couple pictures before and after. So this is a typical assembly built in a UL frame, test frame. Here's what it looks like before a test. Nice, as one would see in final construction in a building. Now we've placed this nice looking finished assembly on the furnace. It's subjected to a 1-hour standard fire, and this picture shows what it looked like after the test. This is a view of the under the roof ceiling, but above the acoustical ceiling tiles. You will see in particular that there is a local buckle in the upper flange of the roof purlin. Also, the fiberglass insulation has melted away. That is gone. But the important point is that the assembly itself is intact. There's been no failures, even though there is some fire-induced damage. And that's the message. You want to avoid collapse, but there will be a limited amount of fire-induced damage even in fire-resistant construction. And that concludes part 3 of this 5-part series. Thank you for your attention.